Welcome back to the channel, guys. Hope you are doing extremely well and welcome to Binary Tree, another lecture. So this lecture is just an extension of the previous lecture. The previous lecture was to discuss level order traversals, right? Level order traversal, a critically important traversal, and I will prove it to you. Why? Because here with me there are three different types of questions which are actually very important from the placement point of view and are actually the extensions of level order traversal. So if you have not gotten your level order traversal correct in your head, then you might be in a problem. So please watch that video before coming here if you are not clear with the level order traversal. Okay, so this is the prerequisite. Okay, this is the prerequisite. Also, we are going to discuss the three questions in a single video, so I'm trying to make it as short as possible, but still it is going to take some time. Okay, now the first question is zigzag traversal. Zigzag traversal. What does the traversal says? So we have studied the level order traversal, right? We have studied the level order traversal. For the given tree, that is this tree, what is my level order traversal? So you will say 1, after that 2, 3, after that 4, 6, 5, after that 10, 8, 7, after that 9, right? These are my level order traversals, right? Okay, but this traversal was something like this direction, then this direction, then this direction, then this direction, then this direction. All right, but now the question demands me to do something like this direction, then this direction, then this direction, then this direction, then this direction. That is, after completing each level, change your course of direction. Okay, so my zigzag traversal will look something like 1. After that, 1 was in this direction, then 3, 2, then 3, 2, 3, 2. After that, 4, 6, 5, 4, 6, 5. After that, 7, 8, 10, 7, 8, 10. After that, 9. After that, 9. This is the only thing the question demands from me. This is the only thing the question demands from me. How will I do it? So if I try to compare this with this, what is actually happening? One is simple. 2 and 3 are actually reversed. 3, 4, 6, 5 are same, but 10, 8, 7 are actually reversed. So if I try to mark the indexes, this is index number 0, this is index number 1, this is index number 2, this is index number 3, this is index number 4. Similarly here, 0, 1, 2, 3, 4. So you can see, if I give the level order traversal, but after reversing the odd indexes, that is level order traversal, right? Reverse odd indexes, right? And then you can just say it is my zigzag traversal. There is also a technique other than that. What is that? So we know about level order. We use a queue, right? We use a queue in the level order traversal. So in the case of when I want the elements to be 3, 2, so what I will do, instead of pushing left and then right, I will be pushing right and then left. That is, this was my previous order, right? Push the left first and then the right. But I can also do it by doing something like this. I push the right first, then the left, and that will give me the same order. But I don't prefer it because that is just increasing the complexity in our heads. So why don't we use the same old method way, because it is giving us the optimized answer as well only. The time complexity is actually the same. So it is more easier than that. And I am here to provide you the easier code that gets you into the companies, right? Now, moving on, zigzag traversal is done. What I will do, I will just make the level order traversal, and for all indexes, I will reverse those arrays, and I've got my answer as zigzag traversal. Now, moving on to the left view and to the right view. Okay, so let us understand what is the meaning of left view and the right view. Okay, so previously in the case of level order traversal, we were actually going through the nodes. That is 1. Then after getting 2, I was going through the node 2, and I was reaching 3. Then 4, going through the 4, I was reaching 6. Going through the 6, I was reaching 5. Then 10, I was going through the 10, I was reaching 8. Then I was reaching 7. Then 9. Right? So I was going through the what do we say? Going through the nodes. But now the problem statement has changed. The problem statement says that all the nodes are opaque. All the nodes are opaque. So if you throw the light from here, suppose you throw the light in this direction, right? Then after coinciding with any node, the light will diminish. It will not go through it. That is, if I throw the light from here, 1 will be lighten up, 2 will be lighten up, 4 will be lighten up, 10 will be lighten up, and 9 will be lighten up. That is, after 2, the light cannot reach 3, and 3 is still in the dark. So I will not be able to see 3. After 4, it will not reach 6 and 5. So 4 is in the light mode, but 6 and 5 are in the dark mode, and I will not be able to see 6 and 5. In the case of 10, I will be able to see the 10, but I'm not able to see 8 and 7. In the case of 9, 9 is the only node, so I'm able to see 9. Okay. Now, I want these nodes which are in the present in the light. I want these nodes which are present in the light. I want these nodes which are present in the light. So as you can see, these nodes are the left ones. These nodes are the left ones. So this is known as left view of the tree. That is, the left view of the tree will look something like this: 1, 2, 4, 10, 9. Right? Is okay. This is my left view. Right, this is my left view. And similarly, if I throw the light in this direction, what are the nodes that will be visible? So it is 1 again with 3, 5, 7 and 9. So my right view, that is my right view, it will be looking something like 1 with 3, 5, 7, 9. 3, 5, 7, 9. This is my right view. This is my right view. And the question arises, how will you solve it? So let me draw the tree in a neat way below. Alright, so here is my tree. So now if I try to write the code down. So see, when I was trying the code, first of all, in the case of left view, I thought that always a left of left of left. That is, I will call a recursive function. I will go left, and if there is a left, I will go towards its left, and if there is a left, I will go towards its left, etc, 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 and I will get the left tree. That is 1. Then I will put 2, and 2's left is not there, so I will go towards 2, right? And then 4's left is not there, 4's left is there, so I will go 10, right? But that is a problem. Why? So if I try to follow this approach, I will be able to put 1 into my answer. I will go to 2, I will put 2 into my answer. I will see 2 doesn't have a left. Okay, no problem. Let us explore 2's right. Okay, because 2 is a leftmost, so its left is not there, so the right becomes a leftmost, right? So put 4 into the answer. Now putting 4 into the answer, I will see 4 has a left. Okay, I go to 10. But the problem arises now. As we already know, our left view is 1, 2, 4, 10, 9. What will you do about this 9? What will you do about this 9? This 9 can only be explored if you had accounted for 3, 6, 5, 8, 7, 9, etc. Right? If you had followed this path also. If you had followed this path also, then only you could have encountered 9. So what will you do about it? Because you were taking care of 2, 4, 10, etc. Right? You didn't care about 3, 6, 8, 9, etc. Right? So that's where when it occurred to me that it is not a correct approach. The correct approach lies in the already discussed approach, which is level order. Right? Up till now, you should be able to visualize what is happening. So if this is my level order, can I say in each level the first element is my left view? The first element is my part of my left view. So what I am saying is, do the same steps as level order. Answer equals to first element of each array. First element of each array. First element of each array. So in the case of level order, the level order traversal is 1, 2, 3, 4, 6, 5, 10, 8, 7 and 9. And if I put the first elements into an array, it will look something like 1, 2, 4, 10, 9. Exactly similar to the one we discussed above, 1, 2, 4, 10, 9. And the answer must be clear to you for the right view as well. What is the right view? It is a last. So if I just extend it by saying answer equals to last element of each array, last element of each array, this will give me the right view. That is, 1 is the last element, 1 is the first as well as the last, 3, then 5, then 7, then 9. 9 is also the first and the last. So this is my left view and this is my right view. That is all you have to do. Just give me the level order traversal. So if you take the first elements, you will get the left view. For if you do the last elements, you will get the right view. That is all. So we will be coding the zigzag traversal, left view and the right view subsequently, and we will be showing you the code. So please stay tuned. Okay. So here is the code for zigzag traversal. So I just pasted the code for level order traversal, which was discussed in the previous video. Again, I am saying, if you have not watched that video, please watch it, because that is a prerequisite. Okay. So I've written the code for level order traversal. After that, what I will do, I will just run through the answer array, that is for int I, going from 0 up till answer dot size. What I will do, I plus plus, and if my I percentile 2 equals to 1, that is or index is present, just reverse it. So reverse answer of I dot begin with answer of I dot end, right? Okay, that is all you have to do, and it will work fine. Let us try to compile and run it, and it is running. Okay, it is running fine. Let us try it for submit as well. Should run fine also. And It is getting accepted. So here is the code for left view. I just pasted the code for level order again here. So sorry, I was not able to find a lead code problem link, so I have to do it on the GFG platform. It is also equivalently fine. We just need to solve the problem. Okay, just need to make some changes. As long as I don't want all the elements of the level order traversal, so what will I do? I will convert it into vector of int answer. Everything will remain same. After that, I don't need an next level for each of them. And at the end, if I equals to 0, that is after popping, if my I is equal to 0, that means it is the first element of the level. That means answer dot push back. What do I push back? I push back the nodes data. Here it is data. In that case, it is level. So, and it is also node star here instead of tree node star. So it will be node star. Okay. After that, instead of level dot push back, I don't have to do anything here, right? And q dot push node left, q dot push, etc. And here it is. Here it is. Okay. Let us try to compile and run it. Hope it will work fine. And we will do the same for the right order traversal also, right view also. Let us try to submit it as well. It should work fine. Getting accepted, I guess, and getting accepted. Okay, so let us move towards the right view now. Alright, so here is the code for right view. Fortunately, I found a lead code problem into it. Okay, now moving on. What I will do, instead of I equals to 0, this is the code for left view. Instead of I equals to 0, I will code for I equals to n minus 1. That is the last element. And instead of data, it will be value. Right? Let us try to run it. It should run fine, I guess. Oh, it will be commented out also. So, okay. Let us run it now. It should work fine, I guess. And it is getting accepted. And let us try to submit it as well for the hidden test cases also. It should run fine. Okay, getting accepted. So, thank you for watching. We'll meet again in the new video, in the new lecture. Please stay tuned. Keep coding, keep practicing, because practice will only make your hand firm in DSA. Okay. We'll meet again. Till then, stay tuned and thank you. Have a nice day.